Welcome to Permaethos TV, episode 5. Today we have with us Brandon Williams. He founded Iron Edison in 2010 with a passionate focus on high-tech batteries for solar, off-grid, and grid backup systems. He's the lead system designer at Iron Edison. He's energized thousands of people into using nickel iron and lithium iron batteries. As CEO of Iron Edison, he's got it to grow 200% over the 5 straight years, and he actually employs 12 people out of Colorado that all focus from things in sales, distribution, and the assembly center. So we're very happy to have Brandon here with us to share his experience and knowledge, and thank you very much for being here with us today, Brandon.
Thank you so much for having me. This is a great opportunity. I love being on the internet and talking to new people about solar and battery systems, and I really appreciate being here with your viewers and listeners. I'm going to go ahead and jump into the presentation. We have also a brand new video, a product spotlight video to debut here after the presentation, so we can do that before or after the question and answer session. So by all means, please submit your questions through the Q&A, and we will get to all those questions just as soon as I wrap up the presentation here. Well, I want to thank you very much for coming today. I am incredibly humbled to be here. My name is Brandon Williams, and I started my own business, Iron Edison, so that I could do something I really wanted to do, to learn about renewable energy. There are many people who have helped me along the way, and I want to thank them for getting me to where I am. My wife, my friends, my colleagues, but many of the people from around here in Colorado as well. I've worked with the State Energy Sector Partnership, the Workforce Development Center. I've worked with Business Incubator, Jefferson County Workforce, the Colorado Center for Renewable Energy. But two of the biggest partners that we've worked with in the development of Iron Edison have been the National Renewable Energy Lab, located here in Golden, Colorado, as well as Solar Energy International, which is one of the premier training facilities in all of the US. So if anybody's interested in furthering their career or learning more about solar energy, I would highly recommend Solar Energy International, or SEI, as having one of the best training programs for solar system design, whether it's on-grid or off-grid, wind or hydro or pumping. They are really a fantastic facility. So this has been an incredible experience starting this business. I originally started Iron Edison working solely with the nickel iron alkaline batteries, which were invented by Thomas Edison over 100 years ago. The nickel iron alkaline battery is the most durable and longest lasting battery that's ever been invented and really brought to market. Thomas Edison set out to find the ideal storage battery, and it took him 10,000 hands-on experiments to find the perfect combination. The same Edison design of a pocket plate battery is still in production today, from China to Russia, Scandinavia, and most recently, with production right here in the United States. So I started working with the nickel iron batteries alone, and then that really developed into working with some of the other equipment. Here you can see inverters, charge controllers, racking systems, battery boxes, and batteries. Then, as time progressed, I started designing, installing, commissioning, programming, and monitoring much larger systems. This is a 1,000 amp hour nickel iron battery. There are 5 of these pole mount solar arrays nestled into the side of a mountain. There's, as I said, the 1,000 amp hour battery. You can see on the bottom left what really the inside the plates look like, suspended from the terminals at the top. And the top left shows 2 SMA Sunny Island inverters in the AC coupled system design. The final product here, the battery is in a ventilated enclosure, but it sure looks a lot better right here without the box in front of it. But for all the battery systems, we definitely recommend safety first, and you will see batteries both in and out of boxes, but in their final configuration, almost every battery that we put in is in a ventilated enclosure. So as time went on, we made a lot of people happy, very happy along the way, which is great because ultimately that's what we set out to do. We think that customer service and customer education is really the most important thing that we could be doing here. We're not just selling batteries, we're really selling solutions to problems. The customer in the top center, whom I'm shaking his hand, his son has an electric wheelchair. So it really is like this is a mission critical application where if the grid is down in their rural area, you know, it's absolutely critical to keep his house energized. You can see other systems here right below that. This gentleman is a farmer up in Connecticut using an old solar array. We also work with survival and preparedness minded customers. In the right side, there's a picture right outside of Moab, Utah. And there's a picture of my lovely wife on the left installing a battery right outside of New Mexico. So as we continue to make people happy, we needed more batteries. So we had to get a warehouse and so that we could fill it up with some batteries. We now have, I can't believe after just a couple of years we're filling this warehouse full of batteries and we're already looking to expand because the space that we have stacked 3 boxes high is simply, there's just not enough room for the nickel iron and now the lithium iron batteries that we design and sell every day. In the back of this picture, you can actually see my forklift, which uses a lead acid battery. And this is, of all the batteries that we have in the warehouse, that battery driving the forklift is the weakest battery that we have. So it's just kind of a testament to the technology of a disposable versus a long-lasting battery. So as we helped more people designing and selling systems and delivering solutions, it took more and more people to help all the people who are asking us questions, who are coming and knocking on our door. Today, we're proud to have 12 full-time employees out of our Denver, Colorado, Lakewood, Colorado facility. We also have 2 additional part-time employees across the country, and we're in the process of interviewing even more applicants as we continue to grow. So it's absolutely incredible to be here today talking to you about this, whereas I started this and essentially as an entrepreneur out of a home office, and now here we are, with the entire team and thinking of the thousands of people that we've helped in the last couple of years. I really appreciate, every opportunity and every system that comes across my desk. So after 5 years of system design, about a year ago, we started seeing the interest in lithium battery systems grow. This was even before our competitors at Tesla were making big headway. We saw this as we saw that this is the next growth opportunity. Here you can see one of my employees with one of my favorite pieces of equipment, the walkie-stacky, in our new lithium production shop. That we basically, again, our hand was forced to move into this facility as our partner who is building the lithium batteries was not able to meet our demand and not able to meet the design specifications. So unlike a lead acid or a nickel iron battery, which is essentially just cabling and connections, the lithium, or specifically lithium iron phosphate chemistry we work with, requires a complex battery management system. Let me turn on my highlighter here so I can show you. In this enclosure here, you can see some of the electronics for the battery management system, including the BMS, power supply, relays, and a sealed contactor that allows us to protect the battery by opening the circuit potentially under load. That's what this device allows us to do. So if someone were to potentially overcharge or over discharge a battery, we now have safety mechanisms built right onto the battery to preserve the life of the battery and allow it to keep working for years to come. So as we learned how to build these lithium ion batteries, we're working with large format, high capacity cells, coupled to a sophisticated battery management system using all the components you see here. Interconnects, fusing. Here's a close-up picture of the contactor that's sealed to allow it to open up under load. You can see these really specialized bus bars that are actually stacked copper plates. Over here, we have a Hall effect current sensor that's measuring energy coming in and out of the battery. And we're putting this all in a UL listed enclosure to make sure that we're delivering the safest possible battery design using this advanced chemistry. So as we learned and we grew, the design was refined. You can see this is one of our 3rd generation designs, a fully enclosed box with a battery management system display on the front, an on-off button, a safety reset. And really we're at the point now where we're delivering a very sophisticated product in a completely assembled package. This really helps during the installation process and the commissioning process. Even with somebody who has hundreds of installations under their belt, it's so much easier to get this plug-and-play solution where we essentially just use a pallet jack, move these batteries into place, make 3 or 4 cable connections, and a very sophisticated battery is up and running in less than 3 or 4 hours of installation. So as this design continued, and these as it's been refined and as our reach has continued to grow, we started to catch the attention of several large commercial customers. What you see here is a project that we actually just completed. These are in the process of installation, 24 Midnight Classic charge controllers, 3 Schneider Electric inverters, the battery enclosure systems provided by Midnight Solar. And then because of the geographical location being so far north, the solar array is mounted in a vertical configuration where the snow and the ice is going to slough right off. And during the winter, this solar array is going to be able to maximize output. So a really unique project up in northern Alberta, Canada here. So as these improved designs looked impressive to folks who managed bigger off-grid systems, we started making even larger lithium batteries than we ever had with nickel iron. The lithium battery provides higher energy density than lead acid, so double the energy density, twice as much power in the same footprint. The lithium is completely maintenance-free, so it's really good for remote applications. And the lithium iron phosphate chemistry is safer than any of the other lithium batteries in its class. Less risky, businesses love that, homeowners love that. And what we sacrifice, we're basically in the rocket fuel category when it comes to lithium batteries. So we're giving up 1% to 2% of performance versus other lithium types to have full safety built right into the type of battery that we're using. So other competitors are using a lithium cobalt blend. Again, our lithium iron phosphate blend is much less susceptible to thermal runaway. It is if we took a nail and pierced that cell, the front of the cell, we would see steam rather than sparks and plasma come out of the front of the cell. So again, this is super high power batteries, but we're going to work with the safest type within that class. So that leads us to this very moment today. We are truly at a crossing point where lithium batteries and solar batteries and solar systems in general are going to have a greater impact than any other technology that's come before it. Take into account the rapid adoption and plummeting prices of solar panels, the timing for lithium and nickel iron and solar-based systems could not have been better. So that's part one of the presentation, just to get you up to speed on the company and the technology and everything that we're doing. I would like to transition a little bit into types of system design, where we are going to talk about a system that's currently installed at my house, as well as some of our most popular system designs. What I'm going to do is clarify the difference between off-grid, grid tie with battery backup, grid direct, and even a new concept that's called grid zero or grid last, where we're still hooked up to the grid, but not selling back, really just using the grid as a generator. So grid tie with battery backup is the first type of system that we'd like to go over. This is consists of a solar array, a charge controller, which is shown right here, a battery, an inverter, which takes DC power and converts that to AC, as well as an electrical sub-panel. What's important here is the addition of a new electrical breaker box to your existing house's first breaker box that was installed. The sub panel, or it used to be called critical loads panel, we now say backed up loads panel, isolates the circuit breakers that feed dedicated loads in your house. And it may not be all of the loads, it may not be all of the circuit breakers, half or sometimes less depending on the size of the house. But these are the circuits, lights, fans, refrigeration, maybe not the hot tub, but definitely the freezer, the pump, anything regarding health, safety, and welfare really is going to be isolated on this critical load subpanel. When the grid goes down, the inverter is able to output energy directly to this critical load subpanel and keep all of those circuits energized, whether the grid is present or not. Other items that you see here, the inverter. The inverter is able to interface with the grid and with a generator, sometimes both at once, so that the system can, at the last moment, if the battery gets low, the system can draw from the grid and keep the system up and running, can keep the refrigeration active, or call on a generator. If we're in an off-grid location and the grid is just not present, we can automatically send a signal to the generator, fire up, run the gen, charge up the batteries, keep the lights on while the gen is running, and turn off that generator after just a couple of hours. It's much more efficient than running a generator for just a couple hours or for running a generator for 24 hours a day. The fuel and maintenance there, the costs get overwhelming very quickly. Next, we're going to look at grid backup or grid zero. This is where we're essentially off grid in the city. The solar comes in and feeds a charge controller, which charges up a battery. Again, this system would have an inverter, a sub panel, but no selling back to the grid. So that means if there's excess solar production, that these solar charge controllers will automatically ramp down production to not overcharge the battery. If we're still in the middle of the afternoon and a heavy load is turned on, the charge controllers will automatically increase the solar production to help offset that electrical load. This is an exact picture of inside of my garage. This is a Schneider Electric 24-volt inverter with 4,000 watts of output. I have 120 and 240-volt loads hooked up to this system. Inside of this box is a DC disconnect and all the circuit breakers for the solar input and output coming through the charge controller. So let's look at how this operates during the day. So what you can see is the solar comes in, charges a battery as DC, then the inverter will take that DC and give it and invert that to AC power for my sub panel to power my loads. This is how my system operates the majority of the day, and it's not until the battery gets low that we'll see that the arrows will change. So grid backup, we are self-consuming energy that is produced by the array. And if a cloud comes over during the day and I still need that to supply my loads, That's what the battery is there for. The solar and the battery are wired in parallel, so they're always working together to feed the input of the inverter. At night, the only difference here is that we have lost the solar input. At this point, the battery is feeding the inverter, DC in and AC out. Keeping my lights on, keeping my fridge running, keeping my fans, staying cool at night. This is a low battery scenario. So now what we're looking at is the grid. The grid is coming on to help support the loads when the battery is low. Personally, I run a very, very small test battery at my house. So what I see is that unless it's fully charged and nobody's been home, my battery may run out at 4 or 5 o'clock in the morning. I could stretch it longer if I really had to, but again, it's just a test battery that I'm running in my system right now. So at about 4 or 5 o'clock in the morning, when my refrigerator comes on and the battery voltage gets down to a certain level, the inverter is automatically programmed to allow the grid to come in, pass through, and support the loads on the sub panel. So what's interesting to note here is that we are not actually charging the battery during this scenario. That's an optional feature or an optional feature that I can turn on and off at the push of a button. If I see the storm is coming in and my battery is low, absolutely I'll buy that extra power from the grid, charge up my battery, and make sure that if the grid goes down, I'm all charged up. But with my system, I know that the sun's about to come up tomorrow morning. Why would I want to spend 5 a.m. till 7 a.m. buying power from the grid when I know the solar is about to come up? Again, all of this is done automatically. I don't have to go in and flip any breakers or push any buttons. And as soon as the sun comes back up tomorrow morning, then I'm back to, sorry for backtracking, then I'm back to this scenario. It's 8 a.m. The sun is shining down upon the solar panels. I'm recharging my battery. My inverter has recognized that there's solar input coming in from the array. It's charging the battery. I've gotten above that preset level, and I now have enough energy to run my house off the grid. So it'll stay like that again until the battery gets below a preset level or meets another condition, like maybe I have to ask my gen to start, or I have to ask the grid to come on, or whatever it may be. Some important features here in this application is that I can, at any given time, and this is especially useful for the permaculture type of system design and in an agricultural situation, we can have a very small size system that's supporting just the critical loads. But we may also want to have a very heavy duty pump on this backed up loads panel. And when that pump comes on, maybe it has to come on at night. In that scenario, I can program my inverter to recognize that there's a very heavy load. Again, I program a threshold. If the load passes above the threshold, the inverter can automatically ask for support from either the grid or a generator or both to be able to support that load until, again, we pass below the threshold, the pump has been turned off. And what this does is preserve what's left in my battery. So rather than taking my battery all the way down as that pump is running, I would much rather keep my battery full all day, ask for a little bit of help from the gen, and when that big pump goes off after filling the trough or watering the crops for an hour or so, we're able to turn off the gen or turn off the grid automatically and go back to running off the grid or off the solar system. So all of these features, again, programmed in right here in this case, in this Outback inverter. Almost every inverter and charge controller we use has these features built in that allow it to automatically start or stop, get grid charge or gen charge, and do load support, or even peak load shaving, which is a new feature coming from some of the other, from in a commercial application, a business may have demand charges. We can use these same load sensing features to offset commercial peak load charges that are on the electrical bill. So again, back to night, from the battery to the sub panel. And then when either the low battery or if we meet a certain threshold of energy needs, then we will use the grid or a generator as support. Here we are at the end of my presentation. This is one of my favorites. A good idea is never lost, even though its originator or possessor may die without publicizing it. It may someday be reborn in the mind of another. I'm not going to take all the credit here, but the nickel iron battery and these alternative battery chemistries, we're repurposing industrial batteries for renewable energy off-grid applications. So rather than looking at the tried and true disposable lead acid technology, we recommend to all of anybody who's interested to take a look at these alternative battery chemistries, to learn about the merits, learn about the challenges with these alternative battery chemistries, and make a really informed decision when designing a really powerful solar electric energy system. So thank you for tuning in to listen to the presentation. And I see there's some questions, so happy to jump right in.